Hi everybody, my name's Paul. I'm going to present this paper, which is going to be my job market paper, and it's going with Aim and Jalal. Title is Disaster Incidents and the Design of Disaster Recovery. So, no, that was really going to be impactful. Okay. Okay, so around the world, natural disasters cause billions of dollars of damage every year. And since the year 2000, we've spent at least $1.8 trillion on the relief and recovery from those events. That's including insurance company payouts, government grants, international aid. Now, where does that money go? Well, the vast majority of it compensates physical damage. So it is used to rebuild public infrastructure, or it flows to people who can prove that their homes were physically destroyed by the event. Now, the majority of the remainder tends to go to a list of geographic units that the government has deemed were affected by this event. Now, the way that those lists tend to get put together is a little bit opaque, tends to be a combination of damage surveys and politics. And if you look at over the last the big disasters of the last 20 years, you see huge variation across events in what's the unit they're using? Are they prioritizing villages, districts, parishes, municipalities? What's the threshold for being included in this definition of you were affected? And the kind of implication of that is you end up with a big mix of the share of directly and indirectly affected people who are being provided with support in the aftermath of these events. And that asks the question that we're kind of really thinking about in this paper, which is, where should you draw the line? Who is affected by a disaster? Or in the slightly nerdier way, we're going to say is, how should you allocate recovery spending across space? So we are going to take the perspective, we're going to kind of answer this question from the perspective of a government who has a fixed amount of money, and after the disaster is hit, they are trying to think about how to allocate that money, and they want to compensate for welfare losses. So you're thinking, what about moral hazard? And I'm saying, we're not going to think about moral hazard today, but you could layer that on top if you wanted to. We have a fixed budget, the disaster is hit, we want to know who experienced welfare losses so that we can target those people. We're going to take 3 steps to try and answer this question. So the first is we are going to write down, I guess, what we call a model of disaster incidents, like a spatial model of disaster incidents. If you're thinking tax incidents, that's exactly why you want to use the word. Think about that same concept. So in the model, there's going to be a bunch of people who are physically exposed to the disaster, like they are literally flooded. And then there'll be some people who were physically not exposed to the disaster. But if there is trade, there's commuting, there's trade in goods, there's trade in intermediates, then the costs of this disaster are going to be shared with people who were not physically affected through changes in prices. So I was flooded and I commute to a different location, like I go and work somewhere else because there's no work where I am, and that's going to push down wages elsewhere. Those people were not physically affected, but they will be indirectly affected by the event. So then kind of what comes out of the model is therefore that the impact of a given flood event on a particular location will depend both on whether it was directly affected and on what flooding was happening everywhere around it. So from the model, we're going to derive a sufficient statistic that allows us to map where was the flood pattern into changes in welfare in every single location. Then, this already tells you all these things. I wonder what's YCI. Okay, so then the next thing we're going to do is I would like to show you that this welfare measure, or this kind of model-derived measure of exposure to an event, predicts or kind of matters for welfare over and above direct physical exposure. And so to do that, we're going to go to a specific event. And our empirical setting is going to be Pakistan's 2022 floods. These were a really large flood. 7% of the land in the country was underwater. 20% of land was underwater in Sindh, which was the most affected province and where our data is going to come from. So if you were going to study an event that might have spillovers, this is a good candidate. We would like to expose, we are going to use cross-sectional variation in exposure to this floods. So what we would like is a lot of really good variation in kind of local flooding, whether you flooded, people around you were flooded. So to do that, we're going to combine geolocated original panel data on 5,100 rural poor households. We randomly sampled these households from a baseline survey 5 years before the floods. We're going to follow up with them 1 and 2 years after the floods. We're going to combine that with geolocated administrative data on physical property damage. So we know the location of every destroyed house in Sindh. And then obviously to map where the flood was, we're going to use satellite data on flooding. I imagine when I said we're using cross-sectional variation, you were thinking about how flooding might be horrendously endogenous and how to deal with this problem. If we can't do a diff and diff, we're going to use a recentered IV. So we're going to use this Borosiak and Hull recentered IV where we're going to simulate your exposure to flooding or your propensity to flood using a hydrological model. Intuitively, we're going to take two people who have the same expected flooding, and one of them, because of exactly where the rain fell, happened to get a really big flood this year and the other one didn't, and that's where our identification comes from. We're going to show you that basically using this, we find kind of two main things. We find that that direct flood exposure, being literally flooded, predicts physical damage, causes physical damage, which you would like to see, but it doesn't affect consumption, what's going on with labor, or your assets, or your probability of selling assets like 1 year after the floods. By contrast, our indirect measure, the one that comes from the model, if you were like controlling for whether or not you were flooded, if everybody else around you is flooded, you're much less likely to be in work 1 year later. So you're less likely to be doing wage employment, you're more likely to be self-employed, which we take up evidence as labor rationing, and you are more likely to have sold assets and you have lower asset stocks 1 year after the flood. All of which we take as evidence that these indirect effects really matter for welfare after a big disaster. The final thing, which I'm not going to get to today, is we are going to then calibrate the model to Pakistan and use it to think about optimal allocation rules after disasters. We're going to compare kind of what would be the optimal rule that would come out of the model with various different types of geographic targeting. But we're not just going to, that's going to tell you that the optimal rule is better than all of those things. What we're also going to do is think about, imagine the planner was uncertain about various things. It was uncertain about exactly who was flooded. It's uncertain about the exact structure of the economy. How well insured are these different policy rules against those uncertainties? Yeah.
Should I think of it as like in the model, the sign of these labor market spillovers is ambiguous, and then you're going to find empirically that it's negative? But like in principle, it could be good for some third location if like people come there after flooding, right? That's just not what you're finding in the empirics, but is the model going to allow for that?
Okay, the model at this stage is extremely simple and was definitely predicted that the spillovers are going to be negative. So at the moment, the way I'm thinking about it is like, we could have taken it to the data and there would be no real spillover effects, and most of it would come through the direct exposure. And yet we see that lots of it comes through the indirect exposure. At this point, I wouldn't say that we could like totally nail, like I'm not going to show you stuff that is completely conclusive that exactly the mechanisms we have in the model are the right model. At the moment, I would say that the model is kind of more illustrative, and then we're going to think about how to enrich the model to better capture the exact mechanisms. I think the real question is like, the real question I think I'm answering is like, how bad are the indirect effects? How important are the indirect effects relative to the direct effects?
I think it might be helpful to like slightly clarify that bullet point where it says derived bilateral exposure of welfare.
Yeah.
To include like through which channels are in the model. You know what I mean?
Yeah, okay. I'm going to do that later, but I agree I can do that now. Yeah.
I'm just wondering if you can talk about what the policy response was, like if there was one.
Yeah, after these floods?
Yeah, after these floods, like
yeah,
did it target the directly affected people, and that's why you don't see much of an effect.
Okay, I'm going to come back to this later because all of the results I'm going to show you, and I think this is a challenge that really faces all of the disaster impacts literature, is we estimate the impact of a disaster, and we're actually estimating the net effect of the disaster and the aid response. So I could tell you a lot about the disaster response in this context. I'm going to show you some stuff later, which is that like basically if more people around you were flooded, you actually ended up getting less aid. So there is some sort of aid rationing going on. A general answer to your question is like the big response were these two things I said, like public infrastructure reconstruction and a huge home rebuilding program. We're actually working with the home reconstruction people to evaluate that project. Then they did a cash transfer, and the cash transfer went to everyone who was in an affected region if they were already eligible for cash transfers. So all of the poor in affected regions, but these affected regions varied hugely in the share of people that actually were flooded. So it provides very different levels of like coverage for indirect damage depending on this like, yes, particularly whether or not you were designated as affected. Kind of interesting.
What is going to be if there is a sort of the welfare measure that you care about throughout the project? Because you mentioned some sort of physical damages, I guess you can measure from the data, or employment changes, or the model is going to give some sort of wages, output measures. Is there going to be one object that you're going to care about, and then design your optimal policy to minimizes the losses in this measure?
I think so. This like kind of is going to stuff that we're not really going to talk about today, but like intuitively, we're going to think about, we're going to have a social welfare function. Into that, we're going to put utilities. At the moment, utility in the model is linear in income. So if I just sum up everybody's utilities, I don't get that much. That's not super interesting. There's not very many interesting lessons you can get from it because the plan is kind of indifferent across all these different reallocations. So for the stuff that I've been doing so far that we've not put in here, we've been like having some sort of like inequality aversion in the social welfare function. I imagine that we'll do something like that. But then I'm also thinking about, you might just think about like some social welfare function, but you also might, particularly in the context of disaster relief, really care about whether they capture those who are worst affected. So I think we're also going to be interested in like how well our targeting rules do at ensuring kind of those who experience the worst damages, which doesn't quite, I'm sure there's a way you could write that down as a social welfare function, but it's a bit more like if I really cared about protecting those worst affected, how well do these different rules at making sure that we protect those who experience the worst damages? So both of those things I think are going to be important to us, but kind of beyond what I'll talk about today. Yeah.
Is there any special about disasters, or is it isomorphic to any negative productivity shocks or taxes?
Say more.
Is there anything special about disasters, or is it isomorphic
Yeah.
to any productivity shocks or taxes?
I mean, no, I mean, yes and no. It is in the model as a productivity shock. There is a large literature on place-based policies or on the pass-through of productivity shocks from one location to what's going on in other locations. The way that we approach it is kind of is entirely drawing on that tradition of how do we think about the pass-through of productivity shocks in one location to another location. I think that what is different is really that sometimes, I think there's going to be a few things. Some of them don't show up on the model yet. Obviously, in a disaster, you often have a bunch of different things happening at the same time, like you're having productivity losses and the destruction of capital, and maybe those things interact. I think the main thing is like just from a policy perspective, we're going to really care about a bunch of people's lives just being totally destroyed, and that might really change how you think about optimal policy because we're talking about like very desperate situations and rebuilding after these disasters. I think there's also something about how disasters are like going to be these we're going to really care about like the spatial correlation in the shock and kind of the scale of the shock. And I think that maybe the kind of literature on, I don't know, maybe I'm overreaching, but lots of those papers I think are thinking just about like pass through of smaller shocks, whereas I guess we're going to really care about, we have these really large scale shocks and they're super spatially correlated. How do we do different policy in response to that? But fundamentally, a lot of it's super similar. And I guess all of the work I know on place-based policy is really thinking about long-term responses to kind of permanent changes in policy, whereas this is really about like, how does the economy respond to a shock, and then how should we do shock response policy? And maybe there's going to be some differences in like what the frictions are in the short term versus long term. That was a really rambling answer. Okay, great. Did I say everything? Yeah. So perhaps this will now answer all of your questions. I'm going to have, for now, an unbelievably simple model of disaster incidents, and I'm having open auditions as to what should be the next thing that goes into the model. So the model is adapted to Pakistan in the sense that I'm going to really focus on labor markets, and I'm going to have rural, because my data is rural poor households. At the moment, I don't have any household heterogeneity, and I'm not going to include goods markets or supply chains or housing, all of which are very kind of variously important in different locations. The one thing I will say is that if I added in any other market which had the same distribution of productivity across space and the same trade costs, then it's going to give me exactly the same, or like up to some sort of multiplier. It's going to give me the same measure of welfare incidence. So that's why at the moment I'm not super worried that adding goods markets is really going to change lots. Okay. Here's my really simple spatial model. We're going to have a bunch of locations. Each of these locations is going to have a set of people who live in that location. And they are fixed in their residential population, like they're fixed in where they live. But what they can do is commute. And they choose to commute based on the wages that are offered by all of the different locations and the travel costs that it would cost them to go and work in those locations. This gives us the classic logic commuting choices, and that is the worker side of the model. On the firm side of the model, we're going to have Cobb-Douglas production in every single location, or every single location is producing the same good. This good is traded costlessly across space. I know it's a simplification. The key thing to know, and this is where the spillover comes from in the model, is that capital is fixed in the short term. So when a flood hits and it changes productivity, this is going to have a direct impact on wages, and it's going to have an indirect effect because people are going to commute across space, and if more people come and work in your location, that pushes down wages. And that is how a flood can spill over onto your location. The labor market's got it clear. I think I already just said this, but what happens when there's a flood in this model? Productivity in flooded locations drops. The wages drop immediately in those locations. The residents of flooded locations commute elsewhere, and that's going to spread the cost of the disaster to those other locations through changes in wages. You had a question?
I was wondering, on the destruction side, would it help to add a housing stock that households consume and get destroyed?
Right.
In addition to capital destruction.
Yeah, totally. I think that's a really important thing. The kind of thing I'd really like to add is, something like this, which is like a consumable, like a durable consumption good. Because if it's just production capital, with this super simple thing, it's like destroying productivity is kind of isomorphic to destroying the capital stock. I guess once, I also think it will be able to help think more clearly about, like, I guess at the moment there is no direct there is no purely direct damages from a flood in this model, because everybody could work anywhere. Whereas if you had people who owned housing in particular locations, there would be a channel of like literal direct damages that you can't kind of share with someone else.
Yeah.
Okay, so from this model, this is, if you've read Benny Kleinman's, Hugh Redding's paper on their friends and enemies paper, it's exactly the same thing, which is that we're deriving how welfare in every location changes when you change productivity in every other location. So this is a matrix that maps a change in productivity in one location to a change in welfare in another location. And what that means I can do, like, think about it, I can take that matrix, I can pre-multiply it by the vector of the flooding in every location. That gives me the welfare effect on every location. So you can see how that would become a regressor that we could put into a regression. The matrix has horrible matrix algebra, but nice intuitive interpretation. So first of all, to understand how welfare changes, we need to understand how wages change. And that when wages change, there's going to be a direct effect and an indirect effect. So when productivity changes in a location, that's going to have a direct effect on wages in that location. So if productivity goes down, wages go down. But then this is going to be slightly offset by the spillover effect, which is that if wages go down in this location, more people will commute out from that location. That will have a slightly offsetting effect. Wages will rise a little bit and will fall in other locations. So we have a direct effect and an indirect effect. Now, so this component now tells me wage changes in every location as a result of the flood. And then we need to map that into welfare changes. And to a first order, the amount that I care about the change in wages in any location is just determined by the extent to which I commuted there beforehand. If I never commuted there, I don't care what happens to wages. Whereas if this was the only place I commuted, I really care about what happens to wage changes. So to turn these into welfare, we just multiply it by what was going on with commuting beforehand. Okay, the key thing about this is that I can estimate this with only data from before the floods, which is nice. Okay, so written down this simple model. From the simple model, we can get how welfare in each location changes when productivity in every other location changes. And it's something that we can estimate with data, and we can turn this into a regressor, put it into a regression.
Just a curiosity, the dimension of spatial linkages, propagation is through the commuting networks in your setting, right?
Yeah.
Why are you focusing on this? Or because obviously there is work on production networks in this setting, right, in Pakistan. Is this also an important dimension that no one has studied, or why this and not?
Why focus on labor? Yeah, so in my mind, there are kind of like these main channels. How do people cope with a disaster, or kind of how are they going to be dispersed? They're going to be production networks, but we're talking, the population that I'm thinking about are like rural poor households. A lot of what they do is like agricultural work, or they do kind of daily construction labor. And so we didn't think that supply chains were first order. Also, we don't have any employer data. That's not the data set that we have, is like employer data and stuff like that. The second thing is that like labor is a key channel. If you are really credit constrained, like labor is a key channel through which, like, it's kind of the main way through which you can go and try and find, you can go and work somewhere else, you can increase your labor supply. So thinking about labor is kind of a key thing. And we also do see empirically like increases in people working outside the village in response to this. final thing is like the other main thing I would imagine is kind of like informal credit networks. But everybody, we had a network module in our survey, and almost everybody's people that they go to if they have a shock was within their own village. And so because this is going to be a shock which affects everybody, pretty much affects everybody in a village, I imagine that's not going to be kind of the main way that people are able to cope with this. So we want something kind of across village, but also that's kind of relevant to our population. So labor was kind of the first instinct because I think it's important, but not because it's the only thing that's important. But I do imagine that the thing that we would add next would be much more along like goods prices rather than going in the direction of like firms and supply chains.
Makes sense.
Yeah.
That's exactly what I was going to say at the end, the goods prices thing. I think if anything you can do to ballpark, like how much of the production is like traded across regions, because I'm picturing like if people are producing food and the food price, like you get a terrible flood, now the food price is high, like that could be good for the farmers in other regions. But if they're like pretty autarkic, then maybe that's like not really an important mechanism for spillovers. But I agree with your instinct that food prices is a good next thing.
I think we have
goods
have a couple of like, there's a couple of interesting directions to go with that. One is that we're in the process of getting price data from Pakistan Bureau of Statistics. We also have some price data just like in the survey. But then we also did this very cool like non-commuting trips module. So we did ask people where they go if they want to go and do purchases. So we're trying to figure out how to use that and discipline that side of it. Okay. Oh, I don't like that. Great, that's loads of time. That's bad. Okay. What I'm going to do is I want to see if you run a regression of your own like direct flood exposure and then the model derived flood exposure, whether that matters for welfare over and above the direct flood measure. So that's exactly the regression I'm going to run. I'm going to take some outcome in my data after the flood. I'm going to do like a direct horse race of the own flooding and the indirect effect. Now, what we would like to do to study this is we would really like to have a big event where spillovers are likely to be relevant. We would like geolocated outcome data so that we could really closely map you to exactly what was going on with flooding around you. And we'd like lots of variation in direct and indirect exposure. And that's exactly what we have. So how did I take so long on that? Right. Intense summer rainfall is not unusual for Pakistan. It experiences a monsoon season every summer. This is showing you normally happens in the months of July and August. So let's start with cumulative rainfall. And this is on average how much rainfall has fallen cumulatively over the course of those 2 months. And the gray is showing you the typical range, like this is a really heavy year, this is a really light year, okay? By kind of the 8th of August in 2022, it sort of looked like it was a bad year, but it was not really like wildly outside of the range of what tends to happen. But by the end of August, it just kept raining. And so this was a very heavy, this is by far the most rain and kind of the heaviest monsoon that they had in Pakistan in like 40 years. Sindh, which is where we're going to focus, is a bit wetter on average than the rest of Pakistan, but it had way more rainfall. And it had way more rainfall outside kind of what Sindh normally gets. So this is just a huge freak rainfall event. And what this led to was huge amounts of flooding. So 7.3% of Pakistan was underwater, 20% of Sindh was underwater. This makes this an event kind of like, I wish I had the percentile, but if I compare this to kind of all of the floods in the Dartmouth Flood Observatory, it's a really, really big flood. Okay, geolocated outcome data. We collect an original panel, 5,100 rural poor households. We randomly sample them from a census of low-income households prior to the floods that we managed to get our hands on. That means we have very limited pre-flood data. We have a household roster, we have GPS coordinates, what they were doing in the labour market and assets. We then survey them 1 and 2 years after the floods. We find loads of them, and we do this very long, everything you would expect to have in a household survey, GPS, household roster, commuting, consumption, health, mental health, all of the above. We then, we also get data on housing damage microdata. So this is property level, 5 minutes. Okay, great. Property level damage data. I really want to show you, okay. We're going to make a flood index. The flood index is going to use satellite data, and we combine this into a singular measure. So when I'm talking about flooding, I'm talking about a measure of flood intensity. And then I'm also going to, in the ways you might expect, convert this into the F-weighted measure in order to put that into my regressions. Now, key thing, flooding is not random. So we're going to exploit this cross-sectional variation in the intensity of in how intensely you were flooded and how intensely everyone around you was flooded. Flooding is not random. you can think of many reasons. I'll let you think of all the reasons you can think of because I'm running out of time. But so what we're going to do to deal with this is we're going to use recentered IV. So what we're going to do is compare two locations that have the same expected flooding, but one had a big flood this year and the other didn't. To construct expected flooding, what we're going to do is we're going to take our knowledge of the fact that rainfall becomes flooding via hydrology. And so we're going to model flooding using a hydrological model. We're going to predict flooding using the 2022 rainfall and using every other past rainfall pattern from the last 20 years, average that, gives us expected exposure. And we're going to instrument for our satellite measure of flooding using the hydrological prediction, controlling for the expected hydrological prediction. Question?
Yeah, when it comes to the understanding like expectations on flood risk, are we including any type of infrastructural consideration? Like to my knowledge, especially in a place like Karachi, for example, like drainage issues can turn even the tiniest rainfall into a flooding event in comparison to other cases. Or are we just looking at like basic rainfall in a hydrological model?
So you can think about it as the variation in flooding that I'm going to use is the bit that comes from the hydrological prediction after controlling for the expected hydrological prediction. So the hydrological model just takes in topography. Like it's not going to have rich infrastructure or information in it, but that's okay because the experiment that I'm using is the variation that comes from my hydrological, like from this hydrological model. Do you mind if we talk about it afterwards?
Sure.
But I think it doesn't matter.
Okay.
Because I'm going to control for the average of the hydrological model that I'm using. And so as long as
You can talk.
Yeah, okay. Essentially what I'm doing is analogous to propensity score matching, but I'm simulating the propensity scores instead of estimating them, because estimating them is like an infeasible problem in this setting. 4 minutes. So first thing I'm going to tell you is that my first stage is great. It's like really great. My F-stats are stunning, and also own flooding IV predicts the own flooding satellite, and the spillover IV predicts the spillover satellite, and they don't predict each other, and it's really clean, and the F-stats are great. And then I'm going to show you my first result, which is I'm going to construct at a local level the share of property that was damaged using the microdata. And I find that a 1 standard deviation increase in the flood intensity in your own location increases the share of buildings that was damaged by 15%. And I also find a very large spillover effect, which is extremely weird because how could flooding somewhere else destroy property here? So the problem that we think that we have when we run these regressions is measurement error. Now, I think you're thinking, which is, well, you've got 2 different measures of flooding. So if you're instrumenting for one measure of flooding with another, why doesn't that solve the measurement error problem? Now, that relies on the 2 measures, the error in these 2 measures being orthogonal. But that's not going to, if I'm using 2 different measures of flooding at the same location, they're not going to have different draws of the measurement error. So if I don't exactly know where these houses are and I accidentally mislocate them in space, then when I construct my IV using the same GPS coordinates, it's not going to deal with the measurement error. And this can generate spurious spillovers because essentially the average of what's going on around you becomes a better proxy of your own flooding. So how do we get around this solution? What we do is we increase the area around someone that we're counting as kind of the direct flood effect. And we keep doing that until we see that there is no spillover effect on damage, on direct damage, like on physical damages. And then use the same specification to look at other results. So we use specifically this physical damage kind of placebo to figure out how big do we need to make the own area until there's no longer a spurious spillover effect. And then go and use the same specification to look at other outcomes. Okay? So I've got 45 seconds, 1 minute, perfect. What I'm going to tell you is that if I increase the buffer until about 4 kilometers, I now no longer have a spillover effect from flooding. I no longer find that this flooding around you predicts physical damage to property. Okay, it's still own damage, own flooding still matters, but the spillovers no longer matter. So now what I'm going to do is I'm going to show you regression results where I define kind of the direct stuff as a 4 kilometer buffer around you. And I'm interested in whether spillovers beyond that still impact economic outcomes. So I'm going to finish on this, which is that if I look at own flooding, I find if I look at the direct effect, I find no impact on expenditure, no impact on whether you're kind of working for somebody else, no impact on self-employment, no impact on whether you sold assets, or no impact on your asset holdings 1 year after the flood. However, if I look at the controlling for your own exposure, what was going on with your neighbors, similarly, there's not loads going on with expenditure. I find you're less likely to be in casual work. You're more likely to be doing self-employment, which is what people tend to do if there aren't any jobs for them to go to. You are much more likely to have sold assets, and you have lower asset holdings. All of this is kind of consistent with it is indirect flooding, which is really mattering for people's welfare after this disaster. Intuitively, if you are flooded but no one around you is flooded, you have access to markets which allow you to cope using these kind of normal markets. You can commute somewhere else. Whereas if everybody around you is flooded, there's no jobs for you to go to, your house is destroyed and there's no jobs for you to go to, and therefore the impacts of the disaster become much greater for you. I'm going to finish because I know I'm out of time, but I just want to end on one other slight tweak to this interpretation is that we find that direct flooding leads to much higher receipt of aid, but indirect flooding leads to lower receipt of aid. So one other interpretation of our results is that this could be being driven by kind of like just poor allocation of aid, that they don't adequately, the aid isn't adequately going to areas which have loads more indirect effects, and therefore if we did aid better, we'd be able to reverse these patterns. I'm out of time, thank you.